It's Carly McAvoy. I'm doing homework 5B today. There's 20 questions. We talked about using a binomial PDF on the calculator for doing this, so I'm going to go through that again, a repeat. They say to use the table, and we're not going to use the table. We're going to use the calculator, but if you would like to use the table, I'm fine with that. Why is that not showing up? Let's see what I got over here. There we go. I'm going to show you the calculator one more time, and then I'm going to assume that you can watch this number to do it. So whenever you talk about a binomial PDF, you need three things. You need n, which is the number of trials, and that's 8 in this. You need the probability of success, that's 0.9 in this problem, and you need x, which is the number of successes, and they want the number of successes to be exactly 8. So what's the probability that if you have 8 trials and you have a 90% chance of success that you will get 8 successes? So we go second function, quit to get out of that. Second function, data. One to the right to get to distribution. We're going to go down to binomial PDF, which is number 4. And then I want a single trial. I have 8 trials here. I'm going to clear that. Just by hitting clear, and then do 0.9, and we want 8 successes, and we calculate that. You have to hit that twice, and it comes out to be 0.43. How far do they want you to go? To 3 places. 430. 4 places. What you'll see is when you get there that you can click on this table and then bring up this table, and you can use the table to answer that, and you can see the answer is 0.430. That's number chapter 5, section 3, number 19. So just use your calculator. Alright, so here's the same thing. We did this in the last homework too. You know your n, you know your number of successes, you know your probability of success. You're going to plug that into your calculator, and that comes out to be 0.127. That's chapter 5, section 3, number 21. So just a little review of that. Here we go. More of those. So you're going to get really good at that. N is 19, X is 4, P is 0.25, and you just plug those 3 values in. All right, that becomes 0.202. So the number 1 they ask you to use the table, and then number 2 and 3 they ask you to use the calculator, but really you can always use the calculator there. Okay, let's see what this one says. This is 5.3.27. Sometimes there's a little overlap in the homework because I want you to practice something more, and so it doesn't hurt to do it again. I believe that we did something like this, but maybe not. Okay, the probabilities were obtained by entering the values n equals 5, probability is 0.771, and there was 10 milligrams of drugs. The subjects treated with 10 milligrams of the drug experienced headaches, 77.1% of them did. In each case, assume that 5 subjects are randomly selected and treated with the 10 milligrams of drug. Find the probability that at least 4 of the subjects experience headaches. So here's the chart down here that they did. I showed you how to do that in the last homework, but I'll show you again how to get the whole chart if you want all of them at once and not just a single one. So second function, data, go to distribution, go down to 4. If you hit 4, you can scroll down to 4 and hit enter, or I just hit 4 because I knew it was at 4 and it brings it up. I don't want a single one, I want a list of them this time. And I know that n was 5. The probability was 0.771. And notice it doesn't ask me for the successes because I want all of them, so it doesn't ask me which ones I want. It says I'm going to put the 0 through 5 in the first column, and I'm going to put the probability of success in the second column, which is fine, and then I hit calculate. And you can see that for 0, my calculator says 6.3 to the negative 4th power, which means we move it over 4 places and it gets 0.0006, 0.0106, blah blah blah. It's the same numbers that they had, but we could do that on our own. We wouldn't have to have somebody do that for us. But when they say at least 4, that means we could have had 4 or 5. So the probability that at least 4 experienced that, we would add those two numbers together, 0.6770. Yep. So that's just adding those two numbers together to get that. Is it unusual to have fewer than 4 subjects? So if this one is 0.6770, this area up here is 1 minus 0.6770. And that's 0.323. And so that's not unusual, because unusual is when it's less than 5%. So B, it's not, the probability that fewer than 4 subjects will experience is not unlikely, because it's got a very high probability, well, 32% chance that that will happen. Okay. 5.3, number 27, chapter 5, section 3, number 27. Okay. All right, we get to put some applications in here. A brand name has a 40% recognition rate. Assume the owner of the brand wants to verify that rate by beginning with a small sample of n randomly selected customers. Okay, so what I know, this is a binomial distribution. What I know is that we're going to look at 5 people. So n is 5. And I know the probability that somebody is going to recognize my brand is 0.4. I already know that because those two things were given. What is the probability that exactly 4 of the selected customers recognize the brand name? Well, if I want to do that problem, I would say n is 5, probability of success is 4, and I want exactly 4, so I want 4 successes, and then I would put that into the calculator. All right? That one answer is 0.077. You can do that in your calculator to find that. B, what is the probability that all of the selected customers recognize the brand name? Well, I've got 5 people that I'm looking at. The probability of success is 0.4, and I want all of them to recognize it, which means I want all 5x. Very low, 0.01, 1% of the time that would actually happen. What is the probability that at least 4 of the selected customers recognize the brand name? At least 4 in this problem means 4 or 5. So we would take our two probabilities, 0.077, and add them together, 0.010. That's the probability of 4. That's the probability of 5. And if we add those together, we get the 0.087. Okay, at least 4. If they said at least 3, you would do 3, 4, and 5, or whatever. If 5 customers are randomly selected, is 4 an unusually high number of consumers that recognize the brand name? Well, we added this together. I got 0.007. Is it unusually high number? Well, you see how that probability is greater than 0.05? It makes it not unusual. Nothing's unusual about it when we get 9%, basically. So it's C, no, because the probability is greater than 0.05. All right? And that's chapter 5.3 again. All right. All right. In a region, there is a 0.9% probability chance that a randomly selected person in the population has brown eyes. Assume 10 people are randomly selected. Okay, so what do we have for our N and our P and our X here for the part A? Well, I know that there are going to be 10 people selected. I know the probability because they told me it was 0.9, and so I need to figure out what X is, or the number of successes. The probability that all the 10 people selected, that's the number of successes is 10. We want all of them to have that, so we want 10 successes here. Find the probability that exactly 9, oh, wait a second. Find the probability that all 10, yeah, 10, okay. Find the probability that exactly 9 of the people, again, we have 10 people that we're looking at. We have a probability of success of 0.9. I can't say that word today. And then I have exactly 9, or 9 people. So I would put that in. What are the answers here? So you can try those and see if you're getting those right. The answer to the first one is 0.349, and the second one is 0.387. Find the probability that 8 or more of the selected people have brown eyes. Wait a second. C. Find the probability the number of selected people that have brown eyes is 8 or more. Well, I just figured out 9 and 10. 8 or more is 8, 9, or 10, right? So I know what the probability for 8 is, and I know what the probability for 9 is. 9 and 10 is. I need to figure out the probability for 8, and then I need to add together the probability that 8 have it, the probability that I will get 9, plus the probability that I will get 10, and when I add those three things up, I'll get my final answer. To figure out the 8 part, hopefully you don't need me to tell you this, but I'm going to anyway. There's 10 people, the probability is 9, and in this case we want the number of successes to be 8. So that's going to tell us the 8, this one told us the 9, this one told us the 10, and when we add all those three things up, we get a total of 0.930. The probability of getting 8 or more people that have brown eyes is 0.930. If 10 people are randomly selected, is 8 an unusually high number for those with brown eyes? I'm not going to answer that one for you. I'll let you do that one on your own. But just remember, we're always comparing our answer with 0.05. Okay, that was 5332, by the way. All right. 14 P's are generated from parents having the green-yellow pair of genes. So there is a 0.75 probability that an individual P will have a green pod. I'm going to write that down. Probability is 0.75. That was just given. Find the probability among the 14 offspring P. So that when we're looking at 14, right? That's our N. No more than one has a green pod. What does our successes look like? No more than one. It can't be more than one. And if I'm looking at 14, I could have 0, 1, 2, 3, 4, so forth all the way down to 14. But no more than one would be cut off right here. In other words, the 0 and the 1. I could have 1, I could have 0, but I can't have more than that. So what I need to find is the probability of 0 and 1. So I'm going to do this. N equals 14. P equals 0.75. X equals 0. Whatever I get for that one. Then I'm going to go back and do N equals 14. Probability of success is 0.75. And X equals 1. And that's going to give me the answer to that because I'm finding those two things and adding them up. I had to figure out what does no more than 1 mean. And it gives me 0.000. Now that is less than 0.05, right? So you can make a decision about whether that's unusual or not. If it's less than 0.05 or if it's more than 0.05. That problem is number 5.3.33. I'm not answering that because by now you should be getting it. And if you're not, you need to go back and watch those previous questions about what makes something unusual and what makes it not unusual. Okay. A TV show, Lindsay and Tobias, recently had a share of 20, meaning that among the TV sets in use, 20% were tuned to that show. Boom. I know something about this problem right there. Probability of success, 20. Assume that an advertiser wants to verify that 20% share value by conducting its own survey. Why would they want to do that? Well, if you wanted to advertise on, pay a lot of money to advertise, you want to make sure that there's people watching that you're trying to get to. And so if you have a show, let's say it's a monster truck pull show, but you're selling yarn, that's probably not where you want to put your ads, because people that are watching that may not be interested in knitting. So you want to make sure you have the share that you think you do before you spend a ton of money advertising. Okay, a pilot survey begins with 14 households having TV sets in use at the time of Lindsay and Tobias. Find the probability that none of the households are tuned to Lindsay and Tobias. None of them are tuned there. So that's N equals 14. How many successes do we want here? We want 0 successes. Find the probability that at least one household. Now, what does at least one mean when you're looking at that? At least one means you could have 1, 2, 3, 4, 5, and so on, all the way up to 14. At least one means one or more. We just found out what the probability of 0 was. What was it? It was 0.044. That's the probability that 0 houses at least one is below that line. So I just found out the probability 0 houses were watching. So if I take 1 minus this probability, that's everything else. And everything else is 1 or more. So that's what we're talking about. So if I subtract that from 1, I get 1.956. Do not round the final answer, then round to 3 decimal places. Okay, find the probability that at most one household is tuned to Lindsay and Tobias. At most one, now that goes back to the other thing. At most one means 0 or 1. That's the most. It could be 1, it could be 0. So we go back up here and do our thing for 0, and then we do the thing for, Binomial PDF. For 1, and that's how we're going to get that answer. At most means everything 1 and below. At least means 1 and above. All right, so we get 0.198, 19.8% if we were going to change that into percentages. If at most one household is tuned to Lindsay and Tobias, does it appear that the 20% share value is wrong? Why or why not? We were expecting to get 20% of the people watching. Well, look at this. This is pretty close to 20%, so I'm feeling pretty good about that. Wait a second. What are they asking? Let me read this again. No, if at most one household is tuned to Lindsay and Tobias, does it appear that the 20% share value is wrong or right? No, because with a 20% rate, the probability of at most one household is greater than 0.05. So when you have that, it's greater than 0.05. Oh, it's asking if it's wrong. Sorry, I was thinking the other way. Sorry, I read that. My reading skill is pretty sucky, I gotta say. So, is it appearing wrong? And the answer is no, it's not appearing wrong. We were expecting 20%, and that's just about what we got. I thought they were saying, is it correct? But anyway, it's wrong because it's not wrong because it's so close to 20%, which is what we expected. The tricky wording there got me. So they're asking, is it wrong, not is it right? And I was answering it was right. 5.3.37. Okay. This is the exact same thing. 75% tuned into that show. Assume that an advertiser wants to verify their 75% share by conducting its own thing. They're looking at 10 households, and they want to know the probability that all the households are tuned in. So we want to look at that. There's the answer, 0.056. We're only expecting 3/4, so a pretty low percentage of the time we'd get everybody watching. Find the probability that exactly 9 households. We still have that same information, but now we're looking for exactly 9. And if we're looking for at least 9 households, we're looking for the probability that 9 are watching and the probability at 10, because at least 9 means 9 plus 10. Oh, so there's your probabilities. When you get the 9 and the 10, you just add those together to get this one. And then this means if at least 9 households were tuned to the TV show, does it appear that the 75% share value is wrong? Why or why not? If it's wrong, no, it's not unusually high, so it's not wrong. Gosh, it's really confusing the way they have that worded. So it would only be wrong if that got 9 households, at least 9 households, because 9 households tuned to the TV show is not unusually high. It's not unusually high, yeah. All right, I'm not loving that question either. But anyway, the way they ask it with is it wrong or is it right really throws me. All right, that's 5.3.39. Let's just move on from my debacle there where I'm getting confused with those questions. A pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test 30 tablets. The entire shipment is accepted if, at most, 2 tablets do not meet the required specifications. If in a particular shipment of thousands of aspirin tablets actually has a 2% rate of defects, what is the probability this whole shipment will be accepted? Okay, what is the probability of success? Well, the entire shipment is accepted if, at most, 2 tablets do not meet the required specification. At most, which means if we have 0 or 1 or 2 tablets that are bad, then it's okay. But we're going to looking at 30 tablets, right? So our N is 30. The entire shipment is if a particular actually has a 2% rate of defects. Okay, so in this one, hang on a second. I was going to flip over here to see what they had on the computer. Yeah, it's 5%, 2%, so these rates are low. I just want you to recognize that when you change this percentage, 2% defective rate is not 2, right? Probability of success is not 0.2. I mean, it's 0.02 because we're going over 2 places to the left, so just be careful. And we want to know what's the probability for 0, 1, and 2. So I want to do, what about x is 0? What about x being 1? And what about, my spacing here was pretty atrocious. X is 2, because those are the all three things that can happen. And I did that while you guys were on pause, so that the probability of 0 is 0.5455. The probability of 1 is 0.3340. You're just going to put that into the calculator. We've been doing that over and over, so I'm sure you feel comfortable with that now. And when you add that up, you get 0.978. Okay. I went out 4 places in. We'll need to go 3, but anyways. All right. Let's go on to something a little different. That was 5.3. We're finally on to 5.4. So we have something besides binomial PDFs to do. So that's exciting. In a clinical trial of a cholesterol drug, 477 subjects were given a placebo. You know what a placebo is. It's in the notes, so we'll talk about that. But fake pill, and 23% of them developed headaches. For such randomly selected groups of 477 subjects given a placebo, identify the values of N, P, and Q that would be used for finding the mean and the standard deviation for the number of subjects who develop headaches. The N is the number of subjects. So N is your people that are in your study, so that's 477. The P is the percent that we're talking about, and that's 23% that was given. Q is equal to 1 minus P. So Q in this case is 1 minus 0.23, and that's how they get Q is 0.77. That's all you do to find those 3 values. And this is 541. Okay, assume that a procedure yields a binomial distribution with n trials, and the probability of success for one